In this video, we are going to talk about aerodynamic terms, specifically how it relates to a plane and how it produces lift. We'll also be relating this video to the FAA Private Pilot Test Prep Book to help you prepare for the Private Pilot FAA written exam. If you have any questions or concerns, feel free to comment down below and I will do my best to answer them as thoroughly as possible. So let's begin with an airfoil. An airfoil is shaped like this. Well, actually, there are multiple different shapes, but this is just what we're going to use today. An airfoil is used as a structure that produces lift. So by definition, an airfoil is a structure that produces lift. An airfoil is in an aircraft. You see one every day. When you look at a wing, the end of the wing that shapes like this is the airfoil. So when you're looking at an aircraft from a horizontal perspective, so if this is you, and you're looking at the aircraft, and you see this sort of shape at the end of the wing, that is the airfoil. So an airfoil has two edges. A leading edge and a trailing edge. So this leading edge is the front of the airfoil. And the trailing edge is the back of the airfoil. So when we're looking at an aircraft and we're trying to define terms relating to the airfoil, we're going to be referring the front of the airfoil as the leading edge and the back of the airfoil as the trailing edge. So when we're looking at an airfoil, there are more things than just the edges. There's something called the chord line. The chord line is an invisible line in the middle of the airfoil that connects the leading edge to the trailing edge. So let me draw the leading edge here and the trailing edge here and show you the invisible line right here. So this line just shows the center of the airfoil in a latitude format or longitude format, sorry. So let me write the definition down here for any of you that are trying to take notes at home. Chord line is the invisible line that connects, the invisible line in the middle of the airfoil that connects the leading and trailing edges. So we use chord line a lot when determining the angle measurements of other definitions such as angle of attack or angle of incidence, which we will be talking about in a later in this video. So far we have talked about an airfoil, which is just a structure that produces lift, a leading edge, which is the front of the airfoil, the trailing edge, which is the back of the airfoil, and the chord line, which is an invisible middle line of the airfoil that connects the leading edge to the trailing edge. Now we are going to talk about relative wind. Relative wind is wind that goes against the airfoil. So when we're flying, and we're flying this way, the relative wind is the wind that comes in the opposite direction, as you can see here, to the airfoil. This relative wind is parallel to the chord line. So if we're traveling this way and the chord line is like this, the relative wind will be parallel and in the opposite direction of, which we stated earlier, where the relative wind comes in the opposite direction of where you're moving. It is parallel and in the opposite direction of the chord line. So the relative wind would be going like this. And if we were traveling like this, pitching up, the chord line would be here, and the relative wind would be coming down like this. So by definition, relative wind is the wind that is parallel and in the opposite direction of the chord line. Now let us move on to another topic. The topic of angle of attack. So the angle of attack uses the two prior definitions we learned about, the chord line and relative wind, and it fuses it together to create another definition. So the angle of attack, let me draw our airfoil here. This is our chord line. This is the relative wind coming towards it. And before I want to talk about the angle of attack, actually, I want to talk about why I'm drawing the chord line this way when it's not parallel like this, as I stated before. So relative wind actually holds multiple directions. So relative wind by definition is simply the wind coming this way. But there's also, actually let me draw another airfoil to define this. So if we have a relative wind coming here, there's also relative wind coming here, and here, and here. Since all of these are in opposite direction of the way we are flying at, which is this way, we would also have it coming here and here. So we have relative wind coming in every single direction. But when we're talking about relative wind specifically, we only mention the two that are parallel, or not just two, but all of the wind that is parallel to the chord line. So now that we have that out of the way, we can talk about the angle of attack. So the angle of attack is the angle of attack, I cannot be seen. The angle of attack is the angle between the chord line and the relative wind at a horizontal stance. Horizontal stance. So when we're looking at the airfoil here, the chord line is going this way, and the relative wind is coming from a horizontal stance this way. The angle of attack would be here. So let's say this is around 30 degrees. The angle of attack is 30 degrees. If we have a relative wind going here horizontally, and the chord line is coming up here, the angle of attack would be greater of around 70 degrees. So as you can see, the higher you pitch, or the higher you raise your airfoil, the greater the angle of attack would be. So that is the angle of attack. The angle of attack could also be changed by the pilot. So the pilot can change the angle of attack. And generally, you do not want too high of an angle of attack, since that will indicate a stall. If you're going too high, too fast, you indicate a stall.